Okay. So this question you all can write later on. So I'll just discuss this question now and we'll solve the sum. And later on you can write the question. It says an automatic machine was designed to pack exactly 2.0 kilo of vanaspati. A sample of 100 tins was examined to test the machine. The average weight was found to be 1.94 kg with standard deviation 0.10 kg. So is this machine working properly? Now see, here we have a sample size given, which is 100 teens, right? And our expectation is an automatic machine was designed to pack exactly 2.0 kg. That means this is our expectation because the automatic machine was designed to be such that it produces 2 kgs of banaspati. Now, in order to test whether the machine is working properly or not, a sample of 100 teens of vanaspati was examined, and it was found that the average weight was found to be 1.94 kg, right, which is less than 2 kgs. That means one teen should have contained 2 kgs of vanaspati oil. And when it was tested whether the machine is working properly or not, in order to do that, 100 samples were taken. 100 samples were taken. Sorry. So 100 sample was taken, and it was found that the average weight of the 100 teens was coming to be 1.94 kg. Okay, and standard deviation has been found it to be 0.10 kg. So this is our sample mean and sample standard deviation. Now, from this data, we have to test whether the machine is working properly or not. So, in order to test whether the machine is working properly or not, we have to assume that the population mean or mu is equals to 2 kg, right? Because that is our expectation. So, we will assume the null hypothesis to be H naught mu equals to 2.0 kg. Okay. So, you can start. You can write the solution. Write down the solution. Right, sample size n equals to sample size n equals to 100, small n. Sample size small n equals to 100. It is given in the question. So first we will write down the information which are given in the question. So sample size n is 100. Then you write sample mean. Sample mean. In bracket write down small x bar. Sample mean equals to 1.94 kg. Sample mean equals to 1.94 kg. This is given. Sample mean equals to 1.94 kg. And sample standard deviation, in short you can write SD, sample SD, which is capital S. And we denote population SD by sigma. Okay, if sigma is not known, then we can use S. I told you yesterday. So write down sample SDS equals to 0.10. This is also given. These three information are given in the question. Then you write down, let us assume the null hypothesis, like that you write. Let the null hypothesis be, let the null hypothesis be H naught, in bracket write mu equals to 2 kg. H naught mu equals to 2 kg. You should be clear about how to assume the null hypothesis. Okay, null hypothesis should come from your expectation, what you expect it to be. And if it is that the and null hypothesis should always be in equals to form, that you should remember. And after that you should use the information given in the question and prepare the null hypothesis. This is the most important part of these types of problems. Okay. So here our expectation is that the machine produces 2 kgs of Vanaspati teens. So we will expect that as our null hypothesis. So you write null hypothesis H naught mu equals to 2 kg. And after that you write alternative hypothesis H1 mu is not equals to 2 kg. You could have also taken mu less than 2 kg. Okay, you could have also done it in that way. One tail test you could have also done. Okay, so are you getting my point? Reena have shown her problems last week, and I don't know rest of you have done or not, but Reena has shown. So I'm saying that she will understand this. That this type of this problem exactly can be done by taking it in equals less than form also, because the information says that it is less than 2 kg, isn't it? That's why you could have also taken mu less than 2 kg. Okay. Answer will be same. Okay. Anyways, let us do it in this way, and you can take it less than also for in order to test whether it is correct or not. All right. So then you write SE, standard error, SE. Next step, no need to write all this line. Okay, just write down this line. Since the population standard deviation sigma, write this line. From however, no, there is a however you can see on your screen right now. After that, the one line is written. That line you write. Since the population SD, since the population SD, that is sigma, is not known, is not known, comma, an approximate value of SE is, an approximate value of SE is, then write SE equals to capital S divided by root over n. This is a formula you wrote yesterday. So you write SE equals to capital S divided by root over n. So we're replacing sigma by S because we don't know the population SD. So we will replace it with the sample SD. So you will write S by root over n. So that will give you S, we know it is 0.10 and divided by root over n, that is 100, root over 100. So solve this and see, you will get 0.01 because root over 10 is 10 and 0.10 by 10 means 0.01. You can use the smart phone. So you will get 0.01. Then you write therefore z equals to, the formula is observed minus expected divided by SE. Observed minus expected divided by SE. So observed mean you write, okay? Observed mean minus expected mean divided by SE. Observed mean minus expected mean divided by SE. So you substitute observed is 1.94 minus expected, that is 2.0, divided by 0.01, which you have got just now by calculating standard error or sample error, whatever you call it. That then if you solve this, you will get minus 6. Then you will get minus 6. Okay, see, we are getting minus because this it signifies itself that this could have been done as a less than sum also. Okay, as less than sum also. Okay, so since we have taken it as this one, no, a two tail test, so we have to ignore the minus sign, because two tail test is with a mod, and mod it removes the minus sign, it only takes the positive value. Okay, so since we have taken it as a two tail test, therefore we will ignore this minus sign. Had we been taken it as a less than sign, then we would have considered the minus sign. Okay. And it would have been less than 1.634, and we would have rejected the null hypothesis, like that. Same answer you will get. Okay. So now since we have taken two tail test, that means not equals to we have taken. So we will have to ignore this minus sign. So you will write, since mod z equals to 6, this line you need to write. Okay, since mod z equals to 6 exceeds 2.58, since mod z equals to 6 exceeds 2.58, comma, we reject the null hypothesis, we reject the null hypothesis at 1% level of significance. You can take 5% also, no problem. Then you will write exceeds 1.96. So, since mod z equals to 6 exceeds 2.58, comma, we reject the null hypothesis at 1% level of significance and conclude that the machine is not functioning properly, and conclude that the machine is not functioning properly. So we had assumed the null hypothesis to be a perfect machine, exactly equals to 2 kg, but it has been rejected. That's why we will conclude that the machine is not functioning properly. Okay. Any question, any doubt you can ask. Any doubt in this problem you can ask. Okay, can I move ahead with the next problem? Can I move ahead? Please tell me. Yes. Shall I solve the next sum? Rina, Vikram.
Yes, ma'am.
Okay. Okay. This problem we'll just discuss in the class, and you will solve it. Okay. We will discuss the H0 and H1, and you will finish it after the class. See, it says, example 14.28 says, a machine part was designed to withstand an average pressure of 120 units. Okay, so this is the um, expectation. A machine was designed to withstand an average pressure of 120 units. So that it can take pressure of 120 units, the machine was designed as such. Now, in order to test, a random sample of 100 size from a large batch was tested, and it was found that the average pressure which these parts can withstand is 105 units with a standard deviation of 20 units. So this is a exactly same type of sum like the one which we did just now. Here we will apply one tail test. Okay, so test whether the batch meets the specifications. Specification is what? The machine should be able to take the average pressure of 120 units. So H naught will be mu equals to 120 against H1. So what will be alternative hypothesis? Now we will take one tail test. We will take H1 mu less than 120 units. Okay. So we will now take mu less than 120. We could have done this in the previous sum also. Okay, but in order to test, just to see whether we get the same answer or not, we will do it in a different way. And rest of it will be exactly same like the one that we solved just now. Mean pressure will be sorry, yeah, mean standard deviation of the sample will be 20. So S will be 20, N will be 100, it is given. So 20 by root over 100, you will get some value, you will get 2. Then you will solve for Z, you will get in minus. Then since you will test this now as a one tail test, that is less than problem, so you will have to see whether the value that you have got, now you will not use mod and not ignore the minus sign, because this is now a one tail test. So we have to take this minus value into consideration. So and we will check it at 1% level and for one tail test. The critical region at 1% level for one tail test is if Z is less than minus 2.33. Then it falls in the critical region. That means we need to reject the null hypothesis. So thus it is, you will get it as minus 7.5. So minus 7.5 will be less than minus 2.33. Right? So we will reject the null hypothesis. Since we reject the null hypothesis, so we can conclude that the machine is not meeting the specification. It's not working properly. Okay. So you will solve this problem and then write the conclusion which in the way which is given in the question, or you can simply write it in your own words also. Okay. So you will finish this problem today. Okay, today, and this more problems, no, these are there, try to solve them also. Tomorrow I'll not take online class, so you can use the time to try these problems also. Try whether you can solve it or not. This will be same as the given formula. As yesterday I gave you some formula for testing means, two means also I gave. So use this formula and try to solve these problems. Example 14.29, 14.30, 14.31. These three problems. Okay, try to solve. I will also discuss on Monday, but you also give it a try whether you can solve it or not. Okay. And if you want more sums for practice purpose, please message me. I will send you some exercise problems to you. Okay. Okay then. This much for today. No students are there. I also not feeling motivated to teach. Okay, anyways. So I've given you attendance, three of you. You can leave the class. See you on Monday.